So here you can see a rough outline of the types of research that's been conducted. You can see there's been a number of aerial surveys, actually quite many over the years. There's been sampling of the hunt, also some continued for many years, over many years. There's been satellite tracking of animals after 1993, and then there has been recent years also genetic studies. We have been played with that, but moving forward, as you will hear in the later presentation. Oh, sorry, that's the wrong one. A defining moment in our knowledge about narwhals came in 1981, and forgive me, I'll not touch upon research before 81. Because in 81, the Canadians made a huge aerial survey of the whole Baffin Bay region. And what they discovered was that there were narwhals all over Baffin Bay, and all these dots represent the flocks of narwhals that were found out there. And that was in contrast to, for instance, the belugas that were only found along the coast, together with walrus and bowhead whales. So that was a new information for us, that there were narwhals all over the place there, and that also triggered our interest in a number of studies that Mads and I initiated in the late 80s and early 90s, which include the development of satellite tracking technology. And our first transmitter type we wanted to use was the so-called yellow submarine. It was always very smart because it could be attached to the tusk of the animal, but it later turned out that that wasn't a good idea for various reasons. But and also modern models are much smaller. But we learned that the way to handle an narwhal in a net, you can just handle it with 2 fingers. Just have to put it in a blowhole, and then it will stay at the surface. And some of you may recognize Nikolaj Jensen from Kulturstock that participated in capturing in Melville Bay in 93 and 94. Then we moved on to Canada, to a locality called Tremblay Sound. The transmitters changed a little bit in shape, and we also did the first experiments with heart rate recorders. But as you can see here, the sea was quite rough, and this Tremblay Sound actually works more like a wind tunnel, where it's blowing either the one direction or the other direction. It was constantly blowing. But the nice thing about Tremblay Sound is there are thousands of narwhals. You can sit on the beach and see them migrating all the day. Something I would like to show to a lot of hunters from Greenland. But because of the wind, we had to build our first field station. Here you see we're outside the field station. And for those who are not acquainted with the area, this is Tremblay Sound here. And we'll later talk about Tremblay Bay, but we've also done fieldwork in Admiralty Inlet. And fieldwork in Canada, that kind of lasted until 2005. The next locality, this Tremblay Bay, that's a much more calm area. There are tons of narwhals, also belugas, and they're interesting because they also moved to Greenland. Problem is that sometimes we had to wait a long time to catch any weight, so that could be very frustrating. But we had the first year-long successes with a new transmitter type that gave us position from the animals up to 14 months, and that's the record at that time, and has not been exceeded later. So this was what came out of these early studies of satellite tracking. You can see this spaghetti tracks of animals from both Melville Bay and from the Canadian high Arctic. They're wintering here in the Baffin Bay region, and this is the summering stocks here in Tremblay Sound, Admiralty and Tremblay Bay. And that was a major new finding that these animals, they are actually connected, and they share some wintering grounds here in the middle of the Baffin Bay. In '92, we had a master student, Hjørnedal, who collected samples from the hunts in Hjørnedal. I unfortunately don't have any photos. It was in November. It's probably dark, so I only have these photos I can show from a similar sampling of belugas in Hjørnedal. But we could use our research at that time, Melville Jensen, as a platform for weighing animals and collecting a very elaborate sample set that has been useful since. It's also given us the estimates of how much a deck you can get out of narwhals of different sizes. Sampling of the hunt in Thule was also part of the program. Then in 2000, I had a PhD student Christine Leider, that were instrumental in developing a number of new studies. She looked at our data from the different localities and found, for instance, that narwhals from Eclipse Sound, the Eclipse Sound population, that's the blue one here, that's this population here, they don't make as many deep dives as those from the Melville Bay population, which is the red one up here, even though they share the same wintering grounds. And she also did some estimates of the predation by narwhals. These are the two wintering grounds, the one that's used by animals from Melville Bay and Eclipse Sound, and the one above is the wintering ground used by animals from Admiralty Inlet. And from the soil surveys, we got estimates of the abundance, or so the biomass of halibuts per square kilometers in these areas here. And from that, we could calculate what was the amount of predation in tons, how much did the narwhals eat in these two areas. And you can see up here in the northern area, they ate a lot, up to 170,000 tons of halibut. So that was also a new way to using the satellite tracking data and the data we got out of the dive information. She also looked at the density, and we had identified a high density area out here in Baffin Bay, and she looked at the density there and found that in some areas the density was as high as 73 narwhals per square kilometer in these areas of open water, where it's kind of a mosaic thing of soil. And then she worked on the data from Melville Bay. We did some additional tracking of narwhals in the 2000 in Melville Bay. These are the different glaciers that the narwhals are visiting, and you see the dots here, the positions of the waves. And from that, she could look at the habitat choices, which glaciers were productive, which were unproductive, and which ones were chosen by the narwhals. And we also had our second field station in Hjørnedal in Karnak, where we tried out methods where the hunters were equipped with their harpoons were equipped with a satellite transmitter that was supposed to throw into the narwhals in the same way as they throw the harpoon when they're catching the waves. And that also worked. It was a lot of work to make it happen, but the transmitters didn't last as long as those we could put on animals that we had in captivity that we handled in nets. So that has been discontinued, and we are no longer using this field station. Then in 2004, a new PhD student, Eva Garde, came into the picture, and she will later present some of her studies. She developed some new methods for age estimation from eye lenses, where you use the aspartic acid plasmation technique, and she's also has been developing methods for reading of growth layer groups in narwhal tusks. And sampling for her project happened among other places also at the Hjørnedal, which is our third field station. We have a wonderful place. We have a tradition, or it's been kind of mandatory that we have local meetings, community meetings to explain our research. We have many of those, and usually there are only 3 or 4 elder women that comes to listen to us. But in Hjørnedal we tried something new. We had a professional clown that was part of the community meetings, and it was a great success. So there were many more people that attended that meeting. Maybe that's an idea for the section for communication here, the part of communication at the Institute. But one important thing that came out of the field station in Hjørnedal was that we were able to capture in the darkness in November, December 2 narwhals, and they moved from Umanak all the way into Somerset Island, which is the stock around here, which is the largest narwhal stock we have in northern Canada, and that's the reason why there's been such a relatively large quota for the hunting here in narwhal, because we believe that hunt is being supplied by animals from that summering stock, which is very important information. But we have actually given up the task of capturing waves there, because doing that in December darkness and so on, that's too difficult. And the next, in 2007, Rikke Duber Hansen started to do aerial surveys, or was involved in aerial surveys, and she's done an awful lot of surveys, and this is just the surveys of areas with narwhals in eastern West Greenland. So she's also done surveys here for large cetaceans and walruses and other things. This is just an example of the result of two surveys in 2007-2019. This is the sightings of narwhals inside the Ingefield Bredning in Hjørnedal. And you have a similar map, but with much fewer sightings from East Greenland. That's from the area between Tremblay Sound up here and Casilla, an area where we're worried about the status of the stocks. You can see in 2008 there was some sightings seen, but hasn't really been seen any in the southern area for a decade, and up here in Tremblay Sound there are relatively few sightings also in 2017. We have a statistician, Susanne Petersen, that has worked a lot with statistical treatment of some of the data we get from some of the instrumentations. We get a lot of information about the acoustic performance of the animal. She's done statistics on at which depths they do these buzzes that they use for echolocation, something I think I also will talk more about. And these are different animals that have been given names by somebody, I don't know why. But nevertheless, so you can see in different areas, this is Øfjord, Gåsefjord, Outer Gåsefjord, different areas of Tremblay Sound, and she does some very smart statistics, and you can also see the calls per minute in different areas. You can see here that they prefer to do the calls closer to the surface, whereas they do the buzzing at depth. And the buzzing is the vocalization that is useful for capturing prey or finding prey. So that has a function that is relating to foraging, whereas this is a communication, we believe, between the animals. Lord Nielsen was part of was actually in establishing our fourth field station, the last field station we've had. This is in Tremblay Sound, there's two houses there, and this is in close collaboration with the hunters there. One thing we have introduced here is to use a stomach pill that records the temperature in the stomach when the narwhal swallow a prey, and it's eat a cold fish, and the narwhal is of course 35 degrees warm inside, but when they swallow a prey of 0 degrees, then this temperature pill sends a signal to a satellite transmitter that's attached to the back of the animal, and that satellite transmitter sends a signal to the satellite, and that goes back to my office where I can sit in my chair and drinking coffee while I notice it where it has eaten something. But the pill is this little thing here that goes into the mouth here, and this is a so-called intubator that's used to feed the pill through the esophagus down to the stomach. So in that way we can get direct evidence of how often they eat and also how much they eat, because data that comes out of it looks like this. You see this is a normal stomach temperature, and then suddenly it drops because they have eaten something, and then while it heats up, this sweet or whatever it eats, the taken heats up, and then it drops again. And this is a prey taken at 117 meters. You see there are several events here. And if you take it over a long time period, then you have the yellow ones are the dives, and the red ones are the drops in stomach temperature. You can see you have a good record of the feeding rates in the animals and how often they feed, which is of course important if you want to look at the multi-species aspect if there's a competition with the fisheries. Susanna Blackwell has been very important in developing this whole acoustic analysis, our whole acoustic insight we have into the waves today with a little instrument called an acouson that is mounted on the back of the animals and records all the vocalizations, all the sounds the animals are exposed to, as well as a number of other things. And here's a data set of this is an animal that's diving, and you can see the light blue areas is when it's clicking, just making little clicks, and the red dot shows the buzzes. I think Arthur will talk more about that. And Terry Williams in 2015 made our studies a bit more physiological, because you both looked at the brain function, brain size of the narwhals, but also at the heart, for instance, where she found that the narwhals have one interesting feature that we have overlooked in the past when we looked at the narwhals, that they have such what's called an arteriosus bulbosum, which is an extension of the aorta just outside the heart. This is kind of a little extra bag it has where it can keep some blood. So on the deep dives, it can kind of pressure the blood slowly out into the arteries, so it can make longer dives. It can kind of hold its oxygen in a little in the blood in a little bag on the outer part, on the distal part of the aorta. This is a smart little adaptation to deep diving. But she has also worked with heart rate recorders, where we can measure how often the hearts are beating in the animal. And by electrodes, it's actually function like an EKG, it's a simple one, but it's good enough for us to show the heartbeats. And the marine mammals, they have this feature where they have a heartbeat that's like ours, about 60 beats per minute. But when they dive, they can go down, they can lower their heartbeats to almost nothing, to like 10-15 beats per minute, just in order not to use all the oxygen in the blood right away. And that's we have documented that for now. And we also look at how that changes with disturbance and how that interacts with their swimming activity when they're trying to avoid the disturbance factor. Otitero will also talk about the acoustics in a little bit, and she's nicely introduced here. And she will be talking about, among other things, also, she's been studying, among other things, the diving behavior, and how, for instance, when they make deep dives, they just simply drop from the surface. And they use their own negative buoyancy and drops into the water, and thereby save energy. But then they need to use the energy to get back to the surface, and that's when they start stroking. So return. And she has also worked with the effects of disturbance. Here we have an experiment where we have a ship that is sailing in the vicinity. This is the distance to shore of the animal, so they have this tendency that they like to move towards the shore when there's a disturbance, and also when there are killer waves. And then this is how far away the ship is during that disturbance. And then under this period here, it doesn't feel so easy to read here, but under this period here, you have a seismic experiment where it's a small scale air gun that's making just a little what's called air bubbles in the water that the mouse can hear at long distance. And you can see that when the ship is about 30 kilometers away from the narwhal, then the narwhal moves towards the shore in kind of avoidance of this disturbance, and it stops its vocal activity, it stops the clicking, and also the calling, and remains quiet on the surface. Quang is a Vietnamese guy that has worked with a more sophisticated way of analyzing our data, machine learning, deep learning, and he has worked with the accelerometer data, which is kind of the movements the animals do in 3 directions, X, Y, Z, doing that, and they sample at 100 times per second, which is a lot of data you end up with. So you have to have somebody that is good at computers, for instance, to look at if you can predict when there's a bust from these data here. And this is useful for if you want to estimate the buzzing activity just out of the accelerometer data, then you also can develop that into an estimate of the predation. But you cannot always collect all the buzzing, because that takes a lot of memory space of your instrument. So it's better to just collect the accelerometer data. Here you have 2 geneticists. I lumped them together. Sorry for that, but to make it for brevity. You hear Marie, she will talk about her results, very interesting results about the discrimination between different stocks in East Greenland. The breakthrough, because of in the past we have kind of given up on the genetics, they couldn't deliver the answers we were interested in. And they have also worked with the hybrid I found in 92, I think it was, on Swastreet, Luna Island in Disco Bay. It turned out to be a hybrid between narwhal and beluga. It's the middle one here, the skull here in the middle one. This is a typical skull of a narwhal, and this is a typical skull of a beluga. And this is what happens when they mate together. And finally, we have a new postdoc here that works with fixed climate change. We will also present in a little while. He has shown how the narwhals in these different stocks here, they have different population size depending on the temperature. That there are more narwhals in the cold areas, and you can see here the largest abundance of weights are found in Canada, whereas in northwest Greenland and mid-east, which is essentially Scotland Sound, and southeast, which is essentially the sea life, they are in very low numbers compared to the abundance we have in northern Canada. She's also working on predictions of what will happen in the future when the ocean, the North Atlantic, warms up, and the prediction is that they will lose some of their winter habitat. You see here already in 2030, it's predicted that the winter habitat in southeast Greenland is gone, whereas a new winter habitat is appearing up in northern Canada. And by 2100, there's no winter habitat left in East Greenland. And that's with a prediction of a 0.4 degrees increase per decade of ocean temperature. So it's when you apply for funding, it's always this gender equality issue that you have to have some of each gender. But so I have to. It's not all women that have been working now. But we also have had some male scientists involved, but they have mainly been dealing with dishes and. And finally, and very importantly, we also had a number of hunters involved in our studies. I can't list them all, and I don't have, there's no space for pictures of them all, but there's a lot. Thank you.